Okay, we're going to be using the double angle formula for sine in order to solve an equation here. The reason I know I need to use that on this one is because I have um, 2 cosine of x and then also a sine of 2x. So I do have 2 different trig functions playing together in this equation, but in addition to that, one of those has an argument that is a double angle. So my first move is going to be to apply that double angle formula to replace that sine of 2x with sine x, 2 sine x cosine x, just using the formula. So once I've got that, I now have all of the arguments just say x, and so I'm ready to do whatever it's going to take to solve this one. This one's still got sines and cosines together within the problem, but it's only got 2 terms and they both have a cosine in it. So I'm gonna factor right from where it's at and see where that takes us. The 2 terms that are here both have a 2 cosine of x in common. So I'm going to start with factoring out 2 cosine of x. So that would give me 1 plus 2 sine of x left on the inside of the parentheses there. Okay, now with each of the factors, there's only one trig function. So from here, oops, I'm sorry. That 2 should not be there. Okay, so from here, I can set each of the individual factors equal to 0. So I've got 2 cosine of x is equal to 0, and then 1 plus sine of x equals 0. Then I can solve each of those equations individually. For the first one there, I would divide both sides by 2, so that would give me cosine of x is 0. And then I could find the angles between 0 and 2 pi for which cosine is 0. Now that's going to happen, since cosine is the x value on the unit circle, that's going to happen on the y-axis. So there would be 2 of those, one at pi over 2, one at 3 pi over 2. Now for the second equation there, I've got 1 plus sine of x is equal to 0. So to solve, I would subtract 1 from both sides. And that would give me sine of x is equal to negative 1. So that means I need a y value on the unit circle to be negative 1. And there's only one place where that occurs, and that would be at 3 pi over 2. So at a glance, it looks like there are 3 solutions, but 2 of the 3 are actually the same angle. So when I present the answers for this problem, I would only present pi over 2 and 3 pi over 2. Okay, now you try the next question on your Google Form.